Welcome to the Micronaut podcast. The Micronaut podcast is a show about the Micronaut framework, a JVM framework for those of you developing any kind of applications. I am your host, Sergio del Amo. I am here today with Cédric Champeau, who is a core Micronaut committer working at Oracle Labs, who actually joined the core team. How long ago did you join, Cédric?
It was mid-June, so almost 6 months now.
Cédric is helping us a ton with the build, so the internal build infrastructure, which is a topic for a complete new episode, which is not, we are not going to cover that today. Helping us tremendously as well with the official Micronaut build plugins, so the plugins that you will use in your applications. User-facing plugins, the internal plugins, and also you have been helping a lot also with the GraalVM plugins lately, right? The official ones.
Yeah, indeed, yes. I'm basically the maintainer of the GraalVM native image plugins, the official ones.
Yeah, because GraalVM now is... So when you use the Micronaut plugin, are you like getting that plugin applied?
Exactly, yeah. So from the Micronaut Gradle plugin 3.0.0 version.
So that's great because that means that not only Micronaut users benefit from your work on the GraalVM plugins, but other frameworks that are essentially allowing users to generate native image will benefit from having like GraalVM like published official plugins, so that all the frameworks, we don't have to reinvent the wheel, all of us, and we can collaborate. I think that's really nice that we are seeing that. I think we are seeing like a really healthy competition between frameworks in the Java ecosystem.
Yeah. Typically, this is how the GraalVM plugin is developed. So we have meetings typically with the Spring team. So we work together to make the GraalVM plugin great, so that we can use that in our own plugins, and then every team implements that the way they want.
That's fantastic.
So the idea is to reuse the most as much as we can.
The podcast typically starts with the agenda, so I'm not going to lose any time. Let's jump to that section, Cédric. So in agenda, we typically plug what's coming. For me, it's coming holidays next week, at the end of the week, so that's great news. So I hope everyone listening to the podcast, which will be published next Monday, has happy holidays by the end of December, and we recharge the batteries in these COVID years, which are being quite difficult for many people. In terms of January, we have a Micronaut security training event, which I will include a link in the show notes. That's, I think, it starts January the 10th, and it's a 4-day, 3 hours a day training. And then we have a Micronaut testing tips and trick workshop, which is Friday the 15th of January. And Graham Roche, Micronaut co-founder, has a talk this is now in the long distance February 2022 in JFocus. And we have another for Grails users. We are going to do, I'll be teaching a training is Grails and Micronaut. So essentially, which Micronaut features can you use within Grails, which is Grails is now has a peculiarity, which is that a Grails 4 or 5 application is you have access to the Spring application context and the Micronaut application context, which is set as the parent context of the Spring application context. So there is a lot to talk about that. So if you are using Grails 4 or 5, or you are interested just on knowing about that, that's happening in February the 16th and the 17th. The last thing that I want to plug for agenda is we keep building a newsletter application from scratch in Twitch every Tuesday and Thursday. We publish the videos shortly after, so I still have 2 videos that I have to publish, but essentially we are publishing all the videos on demand in our YouTube channel. There is a playlist for that, and since we are recording this podcast Thursday the 16th, but we'll be publishing this episode the Monday the 20th, I plan to actually use the Micronaut AOT plugin on Tuesday the 21st. So if you are one of these persons who listen to the podcast episodes immediately when they come, if you join me tomorrow, and by tomorrow I mean Tuesday the 21st, you will see how you can use Micronaut AOT in your own application. And with that, Cédric, we are ready to jump to the next section, which is Level Up. for level up, since I have Cédric here with me today, and Cédric is probably the perfect person to talk about build. So I wanted to talk about different deployment artifacts that we generate and help listeners understand what they are, Cédric. So I'm gonna, essentially. So if I run a Gradle build, if I am using the Micronaut build plugin, the Micronaut Gradle plugin, or if I build my application with Maven, we generate two jar files under build libs. One is suffixed with all, and the other one isn't. What's the difference between them? When people should use each one of them?
Essentially, when you build a Micronaut application, we can generate different deliverables, right? So one, the typical one is the jar file that you have when you compile a library, whatever. And this jar file actually isn't runnable by itself. You would need the class path to be able to run your application. So you depend on Micronaut core, you depend on Micronaut security, whatever, blah, and all those libraries are external to your jar file in general. This is how typical Java applications have been developed for years. But if you think about the good old days of war development, you had this war file, which was actually packaging not only the application classes, your own application classes, but also the dependencies of your application. And the idea is exactly the same with this fat jar, or sometimes you will also find the name the shadow jar. So the idea is that all the dependencies that your application requires are bundled within a single file. And there are different use cases for that, but most likely the reason why most people do that is because it facilitates deployment. Like you only have a single file to deploy, and you can upload that on whatever server, run the application with a single jar. That's it. So it's in general much easier to work with. So this is one way to do it. If you're familiar to Gradle, actually there are other ways that you can run your application. So the Gradle would create a so-called distribution, which is a zip file or a tar file, etc., which actually contains your application jar and its dependencies, plus start scripts like the bash files, the bat files for Windows, etc., etc. So this is also another way that you can create a deliverable for a Micronaut application, like a zip file that you can install.
Are we generating this distribution zip file already with the Micronaut application?
Yeah, we do. Yes. If you apply the application plugin, you get that. Yes.
That's about, it's called this the JIT mode, right? So this is that
yes.
When you are not generating.
So this is for the JVM.
This is for when you are not using GraalVM native image. This is just your
exactly
Java minus jar, and you execute the application.
Exactly. Yeah.
Then our build plugins allow people to, and we have evolved this and improved this process much through the years, and I think now it's quite seamless. We allow them to generate native image of the GraalVM native image of their applications. How will they do that, for example, with the Gradle plugin, with the Micronaut Gradle plugin?
So maybe we should remind what is a native image first, because maybe not all the audience is aware of. So what you can do now with a tool called native image, which is from the GraalVM team at Oracle, is that you can actually generate an application which is compiled for a specific native environment. So you build an application for Linux, so it's going to generate bytecode, which is not JVM bytecode, but actual bytecode for the target architecture. So Linux or Windows or macOS, for people using that. And the way you do that with Micronaut is actually pretty simple, because we integrate this GraalVM plugin natively. So if you call the task which is called native compile, then Gradle would compile the application for Java, but it would also generate what we call a native image and generate that into the build directory. I don't remember the path. it would be printed in a case, and then you get a single executable, which is much smaller in general and much faster to start.
One thing is to run all these native Gradle tasks, you have to be using the GraalVM JDK, right?
Well, it depends.
At least in this case, right? In the case of native compile.
Yeah, so you need to have GraalVM installed,
and it's easy. So I don't want to scare anyone. So if I use and everyone should use it really. I use SDK man, which is under sdkman.io. And you essentially, if you use SDK man, that's a CLI application. You go to your terminal, you write SDK list Java, and you will see like the GraalVM JDKs, and you can essentially like copy paste the 11 version, whatever the latest one is, and you do like SDK use Java and that version, and essentially then you can use just Java minus version, and you will see that you are using the GraalVM JDK.
Yep.
And if you are not using our plugin, you have to run, I think is GU native image to install the native image CLI?
No, the plugin does that for you. If you want to do that from the command line, you have to do GU install native image.
That's only once. So you have to do it only once, and that's it. Yes. Essentially, the next time you swap to this JDK, that's there for you. So essentially, you run native compile, and we essentially are doing all the heavy lifting for you. So essentially, if you are like, this is transparent for you, generating a native image can take a while, right?
Oh, yeah. That's much slower than compiling a Java application, because it has to do a lot of analysis at build time, like compute the whole graph of classes which are reachable, because once you have a native image, actually, you need to know everything beforehand. So everything is known at build time. There's no room for dynamic class loading or dynamic class definition, things like that, which is also one of the reasons why native image doesn't quite work well with Groovy. It can take several minutes depending on the application size. That
will allow me to essentially like generate the native image for macOS. But typically, for example, for me, I develop in macOS, but typically I will deploy in a Unix or a Linux server, right?
Yep.
And if I generate my native image here and I just copy and transfer that to my server and try to execute that will fail, right?
It will. So what we provide to work around this problem is we typically offer you a way to build your application within a Docker container, which would be using Linux. So you have a task, I think, which is called Docker native, something like that. I don't remember the exact name of the task, but the native image would be built within a Docker container, and then the image that you get would run on Linux. So it doesn't matter if you actually develop on macOS or Windows. What you get is actually a deliverable which works on Linux.
The task is called Docker build native. So I just ran Gradle task here in front of me. And we have also another one which is quite useful. Because typically what you want to do is you generate this Docker image, which essentially has a native image generated inside, and you want to push it to a registry, right? So we have a Docker push native, which essentially will allow you like to configure the URL of the registry. So this could be your AWS, whatever registry solution, Oracle Cloud registry solution, Google Cloud, whatever registry solution, and you essentially can push it there. And typically, then your deployment just is like when you start the application, fetch the image from the registry, right? So essentially,
yes,
this is a really, I think this is probably like the easiest. At least we have created a couple of guides which show that this is a really easy path from native image to production, because essentially, like almost like now all cloud providers will allow you like to start a Docker container.
Yep.
And essentially the fact that there is a native image inside, that's completely...
Yeah, because something that we didn't explicitly mention is that there's no way for native image to actually generate different binaries for different operating systems, or whatever you want to call that. So if you're on the Mac, you have to build your native image for Mac, and if you're on the Windows, you have to do it for Windows. So there's no cross compilation.
Yep.
So the only way to work around this problem currently is to run either directly in the environment that you want to build your image on. So if you want to build a Windows image, you go on Windows, or for Linux as a target, Docker makes it quite convenient to generate images.
So just to wrap up the level up section, so essentially I want to just to point people to it's easy to generate a deployable artifact of your application. And I think we more or less can say we have maybe 5 with the distributions that Cédric told us about. So if I run Gradle build, I will have under build distributions, you will find zip files and tar files with the distribution that Cédric mentioned. Under build libs, you will find like a fat jar. That's the jar with the -all, which you can typically deploy to your cloud provider, and with the cloud provider you just run java -jar and execute that. Then you have like the slim jar, which is like the jar without all the dependencies. That's the one without the suffix all. Then you have Docker build native, which will essentially use Docker to generate a native image using GraalVM. And then you have a native image, I think it's called, or native compile, which essentially will generate a native image for the operating system that you are using, right? So those are the 5. Check them out. It's really easy to, and I think this is really important. I want to convey users that, listeners, that it's really easy to actually like not just execute your thing, but actually generate something that you can put into production or into a real server, which is actually the goal of us. Is not just to play with the things, but actually build things that are deployed. And the Micronaut build plugins will help you to do that. And with this in place, let's jump to the main section. So I want to talk about an announcement that we did today, and this is weird because we are talking about an announcement that has not happened yet in time, but we are talking about it is in the past already. So we announced a new Micronaut module, which Cédric has been working on for a while, which is called Micronaut AOT. And first of all, what is AOT?
So AOT is ahead of time. So the idea is to do things ahead of time, and in general, when you talk about that in the companion ecosystem, it means build time.
So right now we support Micronaut AOT. So you will often hear us say about Micronaut application types. That typically is the drop-down that you have in Micronaut Launch. So we support different application types like application, function, CLI application. So right now we have focused to the default one, which is application. So the Micronaut AOT module works right now. In the future, probably we'll make it work for other kinds of applications, but right now it works only for the regular default application. And right now it supports only Gradle, right?
Yes. So Micronaut AOT is a kind of special module in that way that this is not something that you would find on your application class path. This is more of a toolkit which is used by build tools to generate some optimizations. Typically, it would analyze your application class path, generate some optimizations that we're going to talk about, and then the responsibility of packaging everything together is on the build tool. And currently, the experimental version of AOT that we announced is only supporting Gradle. So we will support Maven in the upcoming month, but for now, only Gradle.
So that's the reason that when you read the announcement or you read the show notes of this episode, you will see that there is like a Micronaut AOT module, and that's more or less like the... correct me if I put words where they are not. So this is more or less like the build agnostic logic for doing ahead of time build optimizations, right? And then we have in the Micronaut Gradle plugin itself, we have like Micronaut Gradle plugin logic, so like a extension so that you can configure it directly in your build file, and all the glue that essentially brings the Micronaut AOT module to essentially do this optimization at build time. So this is an important thing is, so let me actually start from the beginning. So the way you will use this thing in your application is, if you are using Gradle, you have like a plugins a block at the top of your build.gradle or build.gradle.kts file. And right there, if you create an application from scratch, you will have like the Micronaut application Gradle plugin and probably the Shadow Jar plugin, I think. And I don't know if they are only those two, I believe. And
I think that, those are two. Yeah.
So essentially, you have to add another plugin, which is the Micronaut AOT plugin, which is distributed as all other plugins to the Gradle plugin portal. So if you go for plugins.gradle.org and you search for Micronaut, you will see like the Micronaut application plugin, the Micronaut AOT plugin. So you essentially apply another plugin. And what this plugin gives you is, and I promise that I will pass the baton to Cédric, is it will, so you know that you have this configuration block called Micronaut, where you configure like the runtime, for example. It will give you like a sub block of configuration, which will be under Micronaut AOT. And an important bit is you can set a version there. So you can override the version that the plugin is bringing by default. And that version number, and this is the important part that all this preamble is about, is that version number is the version of the releases in the Micronaut AOT plugin, right? So if you go to github.com/Micronaut AOT and you search there for releases, those release numbers is the version that you apply there. So you are essentially telling the Micronaut AOT Gradle plugin, you are telling, please use these versions of Micronaut AOT. And this is a nice thing that Cédric did, which essentially allows the Gradle plugin. You don't have to redeploy a new version of the Gradle plugin whenever you create a new version of the Micronaut AOT plugin. So this essentially is really nice because it will allow us to evolve the Micronaut AOT plugin completely independent of the Micronaut Gradle plugin. Really nice.
This is important also for improving the AOT modules independently of the Gradle plugin. So basically, the Gradle plugin would provide this AOT block within the Micronaut configuration, and it provides some kind of DSL which knows about a specific version of AOT, but it's not bound to it. So you could extend the AOT stuff with new modules, or you could use a different version. And even if you don't use that AOT block, it's still usable to use the Gradle plugin. So this is really something which is nice for trying out new optimizations as they go. And the other important aspect is that typically the AOT optimizations are bound to a specific version of Micronaut itself. Because there could be some optimizations which are available, I don't know, starting from Micronaut 3, and that you would have to support in some way.
So essentially, I am a user and I am trying Micronaut AOT. What I have done is I came to the plugins block on the top of my build file, apply the Gradle Micronaut AOT Gradle plugin. Then under Micronaut, I added this AOT. I specify the version if I want to the latest, because I want to try like the latest milestone that we have released. And what Cédric just mentioned is there is a DSL for some optimizations that they come directly from the Micronaut AOT plugin. And for example, I'm gonna try to go with some of the options that we have, Cédric, and you can explain them to users. So the first one, I think...
So maybe before we go with that, I should explain the differences between explain what AOT does in general compared to what we have in Micronaut in general. Because Micronaut is already quite optimized for build time. So some of the people listening now could ask, what is the difference between AOT and what the Micronaut already does? Because typically what we explain is that Micronaut does things at build time as much as it can. So typically would generate some classes during compilation, so to avoid reflection, etc., etc. So this is things that Micronaut users have been used to. But there's a whole bunch of optimizations that actually cannot happen when you compile the files because you don't have the data to reason about when you actually compile. But this is data that you know after, like configuration files, like YAML files, right? Typically your application YAML files. This is something which is data which is totally independent of the compilation process, independent of build time, and we can still do some optimizations about this. So AOT is really about optimizing things which happen after the compilation phase, but that you still want to do before deploying your application. So it's between this phase of having this deliverable that we discussed about in the previous section and the deployment phase where actually you know about a specific deployment environment. And AOT is about this last part, knowing about the specific deployment environment.
Correct. And I think once we start talking about the different optimizations that are shipping in these first milestones of the module, I think it will make sense to people. And the first one that I want to talk about is, and Cédric already hinted about that, is we have an optimization called Convert YAML to Java. So essentially, as Cédric said, you compile your application, Micronaut generates extra classes for you. For example, you have a class annotated with that introspective, will generate meta information at build time about that class. But when you run your application, right, and you have a YAML file, without the Micronaut AOT optimizations, we have to essentially read the YAML file and essentially parse the YAML file and read it. So essentially, what does if a user goes and under Micronaut AOT convert YAML to Java, they set it to true?
Yeah.
What does it mean for users?
So it means that the AOT analyzer would look up for your YAML files that you have on your class path, and it would generate a bean to replace the YAML parsing with this pre-computed configuration. So basically, everything that happens at runtime before is going to be generating some source code, we really generate a source file, which is a bean, which is a property source, and that property source is going to load a hard-coded configuration file from this YAML file. So what we effectively do is that we parse the YAML file, generate some source code, compile this, and then we repackage a different application which doesn't have the YAML files, but instead have beans which provide the configuration. So we substituted a configuration file with a class file.
So essentially, if this is I think for a user, this is the ideal scenario, which is you are still writing configuration in a configuration file, which is easier than creating all different Java classes for your app, and the build tool is actually doing the painful job of actually creating those Java classes, which are essentially a representation of your YAML at build time.
Yes.
So I think this is a really nice and easy AOT optimization, and when you try this optimization, it will essentially tell you that you have to enable another one. So let's talk about what this optimize service loading means.
So when you compile your application with Micronaut, as you said, for every bean, it's going to generate some metadata, like the bean definition, and also something called the bean definition reference. And all your beans have some requirements, probably you have this app requires annotation, etc., etc. And when you start your application without talking about AOT, what the runtime of Micronaut is doing is that it's going to analyze your class path and use service loading to actually load all those beans and evaluate the conditions, evaluate all the requirements, etc., etc. What we can do with AOT is actually change that so that the loading of all those beans is analyzed at build time. So we would evaluate all the requirements of the different beans at build time, and then we can generate some code which is going to tell Micronaut, hey, you don't have to do this class path lookup. You don't have to use the service loader to load all the beans. Here's the list of all the beans that you need to load, and that's it. So it makes it much faster to start, and this is also something which is quite impressive when you especially in the JIT mode. So we talked about AOT, but we didn't mention really that this AOT module is able to generate optimizations for native images, but also for JVM. So typically this optimized service loading thing is really impressive on the JVM side of things, because service loading in general is quite expensive, right? Because you have to look up for all those properties files which declare some services, and then there's class path scanning to do that, and then you have to load the classes. And despite the fact that Micronaut was already quite optimized to do the class loading in parallel, this service loading is quite expensive. So with this ahead of time lookup, actually we can pre-compute everything, and then we can generate a service loader which is much faster and does everything in parallel. The optimization is not so impressive for native images in this case, just because in native images there's no class loading problem. Like there's no class loading at all in a native image. You have all the code already available, so service loading is effectively free for native images. So, but it's interesting in any case, because you can see that depending on the target deployable that you want to use, the AOT stuff is able to generate different sources optimized for each use case. So typically the way that we generate the class loading for JVM is by giving this list of services to load, and then we have code which is going to take all those classes as string references, which is important, and do the good old dynamic lookup, like class for name, whatever, to load everything in parallel. And it's important to use strings, because otherwise if you use some class references, then everything would be serial when you load the class, the runtime. But for the native use case, actually we can use directly the list of class references, because class loading is effectively free. So the code that we generate actually for the native use case is much simpler than the one we use for the JVM use case.
So if I understood correctly, the easiest thing for users to think about is the whole, so as Cédric was saying, like the whole add requires. So we have like this thing that we typically, you will hear about us talking about conditional beans, where you can say only load this bean if this configuration property is present, right? Or if I am running in this environment. And essentially we are, and it makes sense, we are computing all of that at build time, so it doesn't have to be done at runtime.
Correct.
Another optimization that we have planned that's not still implemented in day one, but that's probably something that we'll work on soon, is we want you to be able to write your logback.xml as an XML file, but we will generate a Java pure configuration at build time. So essentially this is the same metaphor as we were like discussing with converting YAML to Java, but this is more like converting logback XML configuration to logback Java configuration. So for users, they create like the logback Java XML files that they are used to, but we do like the conversion at build time. That's the idea, right?
Yeah, that's exactly the idea. And you may ask why you want to do that, but parsing XML every time the application starts can be a bit slow. That's one reason. Like once you have generated that logback XML file and then you package that, actually it doesn't change. So we could feed the logback directly with the model. So that's what we do instead of parsing. That's one reason. The second one is, why would you need to load an XML parser at all? Like we don't have to. So we can avoid loading the XML parsing. And this comes back to the YAML use case. So one other interest of using YAML is that if we convert the YAML files to Java, then it means that at runtime, we don't need YAML parsing at all.
And in fact, for the native image, we don't even include like the snake YAML parser, right?
So it means that when the native image is going to be computed, then we will never reach the code path which actually loads the YAML parser. So it will not be included in the image. So the native image is going to be smaller than what you have with the regular application.
Yeah, that makes total sense to me. Like your application shouldn't need to like shouldn't need to have at runtime libraries that are only like needed once.
Yeah.
Essentially, right? So you just need to read
So it's a bit more difficult to do the same optimization for the JVM, like not loading the YAML parser or not putting the YAML parser on the class path typically, because we never know what the application is going to do. Like it's dynamic. Like your own code could use a YAML parser for whatever reason.
Yeah.
So the only thing that we can optimize is what Micronaut itself is doing. So we can guarantee that we will never call the code which is actually going to load the YAML configuration, but we cannot guarantee that you are not going to do that. So that's why the optimized Java application for the JVM that we'd get would still have the YAML library on the class path. But for native, this is different because the native compile actually analyzes all the code path, and then it knows statically that this code is never going to be called. So that's why the image is.
But even in JIT mode, users, if they know that they are not using the YAML parsing at all, they could essentially exclude that transitive dependency.
Yes.
When they generate.
Yeah. So with Gradle, it would be pretty trivial to do to generate an application which doesn't have the YAML file on the class path.
Correct. So another optimization that you will see that is called pre-compute operations, and this is like kind of an umbrella term to refer to.
Naming is different.
Yeah, the framework sometimes does internally does some operations that they have a lot of permutations and can be like time consuming. And one of them is so when you create a new Micronaut application, right? There is a Micronaut application.name property on your application.yaml file, and we allow you that to override that with. So if you like go generate a Micronaut application, run Gradle build, and then you like do export Micronaut _ application _ name hello, and then you like run your application and have a controller which essentially exposes that value. We are essentially replacing the configuration value with the value of the environment variable, right? And what seems simple to explain, there is actually a lot of calculation on understanding what the different environment variables names could be. And can you explain what's the complexities there and what have we done to essentially optimize these operations?
This optimized operation stuff is really about purely algorithmic optimizations. Micronaut needs to compute for each environment property the list of micro property names that it could potentially map to. You could have environment names with underscores, typically Micronaut _ whatever, but it doesn't necessarily map only to Micronaut dot something. It map to
dash
without the dot, etc. So dash or So you have different combinations, and the more the more environment properties you have, the slower it is because there are more combinations to compute.
Yeah.
And it's done every time you start the application.
Correct.
So it's interesting because you can see that if you actually add some arbitrary environment variables to your system and start the Micronaut application, you could potentially see the startup time increase just because of this computation. So instead of doing that at runtime, what we can do also is do that at build time. So we take all the environment variables that you have when you build, and we pre-compute a cache of environment variable to the list of Micronaut properties. So it doesn't mean that you cannot have later a new environment variable that we don't know about. You can still do that, but at least for the ones that we already saw, we pre-computed the list of Micronaut properties that they map to. So we don't have to do that at runtime anymore. It's all pre-computed.
And this ties into another configuration, which is so these environment lookups and system property lookups. We have like so we have created an optimization which is backed by a class called cast environment, which essentially will, if you enable this optimization, it will essentially what it means is that whenever so we have replaced the. So you know that to get a system property in Java, you can do like system get property, and to get an environment variable, you can do like system getenv, I believe is the method name.
Yes.
And essentially what Cédric did is, if you enable this optimization, we will like essentially create a cache. So whenever if you have already read that environment variable, that system property, next time we'll go through the cache, right? So that's more or less the idea, or?
Yeah, exactly. So something that most people are not aware of is that calling system.getProperty or calling system.getenv is actually pretty expensive, because it has to lock the environment, because it couldn't be accessed concurrently. So it's actually pretty expensive, and if you do that in a loop, typically it would be terrible in terms of performance. So this optimization is really about assuming something that most people assume. Like once you have started the application, you know the environment variables and you know the system properties, and they cannot change. So we just create a copy of the environment and use that instead of calling system.getProperty.
So as you see, there are a bunch of optimizations. So essentially what we want people to do. So one thing that I wanted to call attention is, so we are releasing this as a milestone. So we want to hear feedback from users. So this is a build optimization for, and correct me if you think otherwise, Cédric, this is not just for optimizing your development performance. This is for optimizing the deployment artifact, because this will heavily impact the startup time. And in fact, in the blog post where you announced the AOT module, you can see that for a JIT application, so it will depend, of course, of your application, and we want people to try it out and see it for themselves. But we are seeing like start time type improvements on the range of 30 to 40%. And in native images, like if you do the percentage, is mind blowing. But it's essentially like Gradient native images starting in 7 milliseconds or something like that. So it's essentially like blazing fast. So I don't know what can be faster than that. So essentially, whether you are like deploying Gradient native image or fat jars, you will see like huge improvements. And you may think like, man, but my application is already fast enough. But startup time is really important in many scenarios. So it's really important in all the Kubernetes deployment scenarios. It's important also in functions, really important in functions, because there is like the problem of cold startup. But are there also improvements in memory consumption or not?
It will depend. So if you load less classes, obviously you would need less memory, but there are also things that we pre-compute, so you have to store this data somewhere. So it depends on the optimization.
And I forgot, there are also improvements in native image sizes, right? So the size of the native image will reduce as well. Yeah. Which is important. So there are many benefits. We can say probably that the biggest one is much faster startup time. So this is a really significant leap forward into startup times. But also, like if native image sizes is a concern, this will help you as well there. And yeah, I think the next step for users, Cédric, will be go to the blog post that we will include a link in the show notes. Go to the Micronaut Gradle plugin documentation, where we have a section about the AOT, and you can find like all the explanation about how to configure the Micronaut Gradle plugin. And the last bit that I was forgetting is, so this thing is extensible, so you can expect other Micronaut modules to contribute AOT optimizations. So we already have the extensibility in mind and it's already in place. So that will be something that we can probably discuss with Cédric in a future episode. But expect optimizations coming from other Micronaut Gradle plugins, but you could even write your own optimizations for your particular use case. And if you are interested into doing that, check the Micronaut AOT documentation, which I will include a link in the show notes. but essentially we'll link to it from the docs.micronaut.io. And that will be essentially the reference that you have to check. So just to reiterate, Micronaut Gradle plugin documentation for user-facing documentation, and for AOT optimization builder documentation, check the AOT module documentation. Is there anything else that you want to plug about?
Yeah, just quickly, because we didn't mention that, but we talked about the deployment, different deployment artifacts that we had in the beginning of this podcast. But when you use AOT, it actually generates basically a copy of all those, but with the optimized thing. So instead of having a Gradle run, you would do a Gradle optimized run. Instead of Gradle native compile, you would have Gradle native optimized compile, etc., etc. So the two things are really separate, and it makes it much easier to compare the results and possibly test that your application is behaving correctly after optimizing.
Thanks for pointing this out. I completely forgot. So the Micronaut AOT Gradle plugin will give you some extra Gradle tasks, which will essentially they will have something like optimized in the name. So if you run a Gradle task, that's all, you will see like Gradle optimized run. So we typically run a Micronaut application with Gradle run. So you have it optimized run for running with the optimizations. You have also like optimized Git all, I think, to generate a fat jar with the optimizations. Yeah. You have also like a native optimized.
Same for Docker, same for the fat jar. Etc.
So for all the deployment scenarios that we talked back in the level up section, you have equivalent Gradle task for the AOT. So please check them out. This is a call for feedback to the community. So we want to have to hear feedback and hear what issues are you facing and what things can we improve, whether it is documentation or bugs that you find or feature that you think that it will be cool to have there. We are really open to feedback, so please use either the Gitter community, the GitHub repositories to submit that feedback. Do you have anything else from the AOT, Cédric?
No, that's a good introduction already.
Yeah, I think so. So thanks everyone for the checking the AOT. I'm gonna jump to thanking the sponsors. So for sponsors, I am happy to announce that we have a new bronze level sponsor, which is Visor Games. I will link a link in the show notes to the announcements. So we have currently 3 sponsors. OCI, which is the Micronaut Foundation ambassador sponsors. Safri.net, which is a bronze sponsor, and Visor Games, I just said. And I would like to thank also the community sponsors. So if you are either an individual who wants to support the foundation or a company, visit micronaut.io/foundation/sponsors to find more information about different sponsorship opportunities there. And with this, Cédric, I think I'm going to wrap up the podcast for today. I want to thank everyone for listening. I want to thank you, Cédric, for joining me today. Where can people find you, Cédric, on the internet?
So they can follow me on Twitter with @Cédric Champeau.
Has a blog where he writes like immensely lengthy blog posts, where he has like almost books each blog post. So that is in melix.github.io/blog. So I will include a link in the show note to Cédric blog, a really interesting blog. As I said before, give us feedback because we really appreciate it, and try the Micronaut AOT and enjoy it, and enjoy this monumental leap forward into startup times. And we hope that you are as excited as we are. And as I said in the beginning of the podcast, happy holidays to everyone, and we see each other in January.